Hey guys, Mr. Bowman here. Today's video we're going to carry on with the sine rule, and we are learning to apply the sine rule in context to solve problems. We're going to start off with a question that we've been given by the triangle. We're looking to calculate x, and in addition to that we're trying to find out y, and we're also going to try and find out angle z as well. So let's start off with x because that's what we've originally been asked to do. So let's start labeling our triangles. So here is side A, which means, angle A, opposite is sine. So here we've got side B, that means that there's going to be little b, and 60 degrees will be big C, and that will be little c. From there, we are trying to find A, so we're going to go A is equal to, A divided by sine big A, that's going to be equal to, and we need to pick the sides where we know both. And in this case, we know both of the C's, so we're going to be working with little c and sine big C. Once we've done that, we can now substitute everything in. So x divided by sine 80 degrees, and that's because it's opposite to x there, that's going to be equal to 7 divided by sine 60, and that's opposite those ones. We can then use our rearranging skills. So x is going to be equal to 7 divided by sine 60. That's going to be multiplied by sine 80. And from there, x, if we put that on a calculator, that's going to be equal to 7.96. There are no units here, but you should be including units if you can. And that there was rounded to 2 decimal points. From there, let's clear our triangle and we can update what we know. So from there, we now know that x, that's 7.96. We can then want to carry out, we did want to figure out y, and we do want to figure out angle z. So the good thing is, angle z, that's going to be a bit easy because all three angles in a triangle, they have to add up to 180. So that means 180 minus 60 minus 80, that there comes to 40 degrees, which makes z 40 degrees. So again, let's rub out z, and let's put in our new value there. And our last step, we now want to figure out side y. And the cool thing about side y is that we can actually use any combination of these. So let's label our sides again. So big A, big B, big C, little c. And just to confirm this, so we're trying to find out the B values that sit in the middle there. So we're going to set up our equation. But what we can do is we're going to test, it should work with both of the A values, and it should work with both of the C values as well. So we're going to set up two equations here. So little b divided by sine big B, that should be equal to A divided by sine big A. And next to that, we're going to go B divided by little big B, or sine big B. That should be equal to the C version of those. And if we go through and do our maths correctly, both of these should come up to the same answer. So in our case, B is going to be y, and the opposite angle is 40 degrees. So y divided by sine 40 is equal to, and we're going to do the same on the other side, y divided by sine 40 is equal to, then let's have a look at the A values. So little a was the 7.96 that we figured out before. That's going to be divided by sine 80. So sine 80. We're then going to do the same for C. C is going to be 7, and that's going to be divided by sine 60. For both of those, we're going to get into some rearranging. So y is going to be equal to 7.96 divided by sine 80 times sine 40. And then on the other side, y is going to be equal to 7 divided by sine 60 times sine 40. And if you put both of those into a calculator, we get 5.2 units. And the first, or both of them, were rounded to 1 dp. So that's awesome. That confirms it. So if you got too much information, you can kind of just pick any of it and you'll still get the right answer. So what I'm going to do is I'm going to pause the video here. So if you haven't got the working down, make sure you get it down. And then we're going to get into our contextual example with this scenario. Okay, guys, we're back and we're into our contextual question. This time around, there's no pictures, no words. We're going to have to sort this out all ourselves. So I guess to start off with, we're setting up a sailing course. And from the start line, so let's draw our start line. So over here, we're going to call that S for start line. The boats will go 5 kilometers north. So that's 5, and then 2 kilometers west. And I just realized that question should actually say east. So I'll update that now. And that there gets us to buoy A. From there, so that means the boats are kind of traveling on this dotted line here. From there, we travel south 3 kilometers. So let's go down here. And that gets us to buoy B. And then they travel to the start line, which is also the finish line. So there's our diagram. We're going to now get into the question. Suppose the first step is we don't actually know any of the sides. So what are we trying to figure out? The total course, which is that side, and that side, all added together. So we are trying to find S to A to B, which we know already, that's 3. And then we're trying to find B to the finish. And we don't know that top one, and we don't know the bottom one. So I suppose the first start is we should easily be able to figure out A to S. We're going to call that there X, and that's just based on Pythagoras' theory. So A squared plus B squared should be equal to C squared. And from there we got 5 squared plus 2 squared is equal to C squared. So 29 is equal to C squared. C is the square root of 29, which comes to 5.4 kilometers. And I've rounded that to 1 decimal point. So let's update our diagram for that. That there is now 5.4. We now need to get into the other bits, and the only issue is we don't have any angles. So we don't have this angle, we don't have that angle, and we don't have that angle. But what we can do is we can use trig to figure out this angle here. So we're going to start off by figuring out this, and then both of those in there become a right angle. So we're going to call this y. So y is going to be equal to tan angle equals O over A. So tan angle is equal to, so there's the angle, so there's the opposite. So that means it's going to be 5 over 2. Delta is equal to be inverse tan 5 over 2. And that becomes 68.2 degrees. And that means we can then go away and figure out angle Z, because both of those form that right angle that I mentioned before. So Z is going to be 90 minus 68.2, and that there is going to become 21.8 degrees. And I just realized both of those were rounded to 1 decimal point. So let's clean up our diagram a little bit now. So just cleaning that up. So we got this angle here, and that there is 21.8 degrees. So we still don't have enough to find out what we're looking for here. So we need to do a bit more work now. And just to explain why we need to do more work. So if you have a look at these opposites, we've only got one of those because we don't have that far side. If you have a look at these opposites, again, we've only got one of those. And if you have a look at these opposites, again, we've only got one. So we're still short a little bit of information. So I'm just going to add in some working in the green pen here. So if we go across here, we can actually form another right angle triangle. And the diagram is very much not to scale, but that there is 2, and that there is 2 as well. And this angle here would be a right angle. So if we add on this angle, that will be able to give us the angle in relation to B. So we can again use our trig to find that out. So this one here we're going to call angle A. So up the top, so it's going to be tan delta is equal to O over A. O over A is 1 because it's going to be 2 over 2. So angle is equal to be -1, 2 over 2. And that means our angle is 45 degrees. Oh, I wrote 4.5, but that's 45 degrees. So that means we've now got angle A. And when we get back, oh, I'm drawing meant to be rubbing that out. And when we get back to our diagram, we can now see that that big one there, that's going to be 45 plus 90. That gets us to 135 degrees. And that there has an angle. So we now have the opposites of those two that we can use to find out our missing one. Our only other missing side is along the base there. Okay, so let's get into that. So let's label our sides. So we've already got A and B, so we may as well run with those. So that means that there will be little b, and that there will be little a. The start would have been big C, and that there would have been little c. So because we're trying to find A, we're going to start off with the A's. So that's going to be little a, because we don't know that, divided by sine big A. So little a divided by sine big A. We then need to pick the other bit of information where we've got both sides, and we've now got both of those sides. So it's going to be B divided by sine B. Let's substitute all our information in. So we still don't know A, but that's going to be divided by sine 21.8. That should be equal to B, which we figured out to be 5.4 kilometers. That's going to be divided by sine 135 degrees. So that then means A will be equal to 5.4 divided by sine 135, and that there's going to be multiplied by sine 21.8. And when you put that into your calculator, A is going to be equal to 2.836 kilometers. And I rounded that to 3 decimal points. And from there, we've now got all 3 parts of our course. So if you draw our course again, so there was our start line. We went to buoy A, we went down to buoy B, and then we went back to the start, which is also the finish. So we know that this one here is 5.4. We were told that one there is 3, and we now know that is 2.8 kilometers. And I've gone ahead and rounded that a bit more to 1 decimal point. So that means the total course length So we're answering the question. That's going to be equal to 3 plus 5.4 plus 2.8. And when you add that all together, so we've got 8.4 down here, plus 2 makes 10.4, plus another 8 makes 11.2 kilometers. And that there is a rounded estimate, 1 decimal point. So the contextual question we just did, it was a very complicated question, and there was a lot to it, but we did end up using the sine rule to help us solve in the end. So hopefully you found this video useful. Today's questions will be a lot easier, so let's get into heaps of practice.